Hi to all. So today this is a project from Birder, and I love this membrane, this tensile structure. So today we will show how to make the form finding of one of these conical shapes. So it could be a good exercise to learn a few new things. Okay, so start. I don't have the dimensions of that one, so we will draw something similar, not exactly the same. Let's start. First thing, I will create a new layer and name it construction layer, and let's draw in plan. Well, let's say that one module is about 20 by 30 meters. So I will create a rectangle by corners, starting at the origin, and then relative 20 meters wide and 30 meters long. So this is my plan. Let's draw a line, a middle line, like that, and a middle line here. Okay. So 30 meters by 20 meters. Start drawing some vertical curves here, and let's say that this is 13 meters high, and let's copy this one. So let's copy this one from here to here, and the center of the conical shape, let's say it's about 2 meters away from here, and the tip point, let's draw another circle, intersection, center radius from here, and let's say it's about, let's draw it like that, so quadrant. So this is our plan. Let's see in isometric. So I want to put on this angle, I want to put my conical shape. This is, and my center point is in the center of this big circle here, and let's say that this one is about 16 meters high. So this is basically what we want to do. Yeah, that seems okay. First thing, so UCS vertical by 2 points from here to here, and we will draw an arch from this point, start point, end point, so from here down here, and this is my starting arch. I will copy this one and put it on this side. So let's draw the back line here, and okay, I will move the construction plane, place it in the middle, and I will draw I will draw an urbs curve, middle point here, middle point onto this one, and yeah, down here. E end to complete. So this is my it's this curve here doesn't matter so much for the membrane, only for the top part. It will give us the shape here in this area. It will give us the shape of the conical tip, so we can fix it a little bit until we don't like it, like this. Okay, fine. So UCS world. So this is my construction. Last thing that I need is an ellipse from by 2 radiuses from here to here and like that. Okay. What we need now is a surface between these curves. We have different methods for making a surface, but the simplest one is a sweep. We need a rail. This is the rail curve, and then we need the profiles, and I will select in order the 3 profiles. Right click to confirm, and I have my surface. What we need now is this curve, this elliptic curve, projected on my surface. So we will use this tool, project curves on surface. Select the surface, this one. Select the curve, this one, and we have the curve projected on top of my surface. Last thing, we have a tool here, trim a surface. So select trimming curve, this one, click inside, and to clear the part of the unneeded part of the surface. So save. Okay, so we have built part of the surface, but this is just CAD information. We would like now to make a tensile structure model using this surface as a base. I will create a new layer, call it membrane, activate the membrane, and create a new tensor group, and activate the tensor group. Okay, now we need to mesh, to make a mesh out of this surface. I forgot to say that for using this technique we have to use the update reference or the NFDM, natural force density method. So since the natural force density method is available to everybody, I will use this technique. So we are using, we see here in the left, top left of the window, that we have activated the NFDM solver, the natural force density solver. We have the surface, we have a tensor group active. We select the surface, and in the FEM tools we have the tessellate command. So let's click with OK, and we see that this nice mesh has been created over the surface. Okay, let's hide now my construction. We see that the mesh is upside down, the positive side is downwards, and negative side is upwards, and we can fix this in a very simple way. I double click on the mesh to select it, and then we have this tool, flip orientation, and my mesh has been flipped upside down. So now I have the top side is the correct side. Okay, we have a mesh, but we don't have the edges of this mesh. We need the edges to add cables and beams and fix and so on. Of course, we could draw them manually, but that would be quite a long time. But we have another tool here, and this tool is this one, and it's called boundary mesh. Boundary mesh means detect the edges of a mesh and create a boundary for me. So let's recall boundary mesh. Two red dots come up, and in this moment the command is telling me that he has detected two edges. So one edge will start at this red dot, and it's a loop that will be closed again on the red dot. For the elliptic hole, again we have a starting point at the red dot, and one single loop, it will be closed again on the red dot. We don't want that. For the conical loop, one curve, one edge is fine, but I would like 4 edges on the boundary of my membrane. We see here that we have a max deviation in degrees. It's 360 degrees. So let's change this to a small angle, 30 degrees. And that means when you detect a corner in the edge bigger than 30 degrees, split the edge at that point. So once you click enter, you see that he has recomputed the edges, and now I see 4 red dots. 4 red dots means that I will have one edge that goes from red dot to red dot, another one, and 4. And of course one single loop in the elliptical ring. So if I am happy with this, click on apply, and we see that 4 edges have been created. That's it. Now I will double click on this tensor group. This is it's an edge group, really. Edges. So select all the edges. I want to fix the edges on beams, so these will be beam elements, non-linear, and I will flag them fixed. Fixed means I'm not really interested in the structural behavior in this moment. I just want to keep the membrane fixed over these edges, since I am searching for a shape. I need to apply a cross section, but any cross section is okay, since he will not use them in this moment. Save. So we have the mesh. Remember that we are using the NFDM method. We are using the natural force density method. That means that my mathematical model is a triangle mesh. We have no FDM mesh, linear net, in this model. The last thing that we need to do is to set the properties for the mesh. Set the properties. When we are using the NFDM solver, we have to set up to tell the software which is the warp and which is the weft direction. For doing this, I will use the place UGS by 3 points. My first point is down here. Okay, any point here is okay. Another point here, and another point on this plane down here. So I have placed the UGS in the plane of the mesh. After that, we right click on the mesh, and we have this tool, warp weft mapping. Set warp weft orientation. So we want to say that the current XY plane, so the current plane, the current UGS plane, is the weft plane. That means that all the cuts if I think of a plane that is cutting my surface, all these cuts will be weft curves. Of course, the opposite curves will be warp curves. So just close with OK. Double click on the mesh, and we can see here the properties of this mesh. The warp and the weft prestress. This now, the units of the warp and the weft are those of the model, and in this moment they are kilonewtons per meter. So we are asking for a warp weft prestress of 1 kilonewton per meter. The material, I can select one of the materials from the database, and the membrane is form find deformable. I want to find the shape of this mesh. Since we have fixed the boundary beams, we don't need to fix the nodes. The nodes are fixed automatically by the fixed beams. So save the model, and we can run the form finder. As we can see here, we are using the NFDM solver. This solver will ask us how many loops, outer loops, and how many inner loops. The number of outer loops will give us the accuracy on how much we reach the desired pretension. So to reach a perfect prestress of 1 and 1 kilonewton per meter in the warp and the weft direction, maybe we need more loops. But if I don't care about the prestress, I mean, if I don't care that the prestress in the membrane is different from 1, I can leave just one loop. Now we must say that for a conical shape, it's almost impossible to have a constant prestress. That's a minimal surface. So I could just put one loop because I'm more interested in the shape of the membrane than in a perfect prestress of 1 kilonewton per meter everywhere, because that's a minimal surface, and I know that a minimal surface does not exist for this shape. So close with OK. He will run the analysis and find the shape. The mesh is quite big, so it will take. That's it. We have our mesh. We can see the final result of our form finding, and let's go into the plot options. We have only the results after form finding, and I want to see the membrane stresses. Let's check off the membrane, and here are the stresses in the membrane. So we see the blue is 1 kilonewton per meter, but of course going near the top ring we are reaching a higher prestress up to 1.92 kilonewtons per meter. Very nice. Let's give a look at the other stresses. So sigma 1 and sigma 2 are the maximum and minimal principal stresses in the membrane. And here we have 0.4, 0.5 is the blue stress, so it's nearly very, very low. The red is 0.99, so it's almost 1. So we have made a very nice mesh here. The last, let's give a look at the von Mises stresses, and we see that we have perfect 1. The blue is 1, and it reaches 1.8 here in the tip point. Very nice surface. Let's take off the stresses and hide the mesh. I will activate now snap to node, browse, and if I unhide I would like to select everything here. I go into the CAD tools, use the copy tool, and copy from here to here to here. Make 3 modules. We can even make Let's make it big. Make another, this one, and copy it down here. So I will hide my construction, and we see that we have a nice made for perspective. Like that. Let's change the color of the membrane, put it white, and let's see the effect of this shape. So in the render we will activate the sun, activate the ground plane, and let's change the hour and real time to show the shadow, and okay, here change the month, and let's go a little bit down with the ground plane, and that's it. Here's my result. Okay, that's a nice result for a very short tutorial. Thank you. That's all for today.